All right, so we have one more talk by Dmitry. So Dmitry is going to talk about also about regulatory reporting, but it's a different system that we have for regulatory reporting. This system, unlike the one that Andreas showed, is completely written in Python, and it also manages to work with millions and millions of files. So give him a hand. Thank you.
Okay. Hi, everyone. Thank you for coming. So I'm going to talk about so-called Reg v1, which was prior to Reg v2 that Andreas described. It's written fully in Python, and basically it deals with post-trade reporting as well. And post-trade reporting means that we do not process transactions live. We do it in T+1 mode, which means that clients trade, let's say, Monday, and they send us transactions for Monday on Tuesday, and that's it, etc. And if it's, let's say, Monday, they send us Friday's transactions. Okay, so post-trade reporting is obligatory for legal entity, any legal entity that is involved in any trading activity. So, and Reg v1 system deals with three main repositories, which are DTCC, CME, and Unavista. Every trade repo has its own format and its own complexity. Let's say DTCC used to have 1,000 fields per record, 1,000 fields, but now it's much less. So we are lucky to have that. Okay, here is our system as seen by our clients. It's I won't show the complexity showed by Pavlos. It's how our clients basically see us. So they send us trade data, they send us some auxiliary data which might be related to either prices or users that actually perform the trades. So we call it like users, but those are clients of our clients. So then we validate the input data, which is we're not so much strict about the format or the source of the data. As Evgeny mentioned, we can process files from SFTP. We can use database connections. We also process files from the emails. That doesn't matter. So, and after we have validated the data, we basically divide it into two flows. One of the erroneous data, which goes straight into the reports notifications and reports about those notifications. And valid data is then processed further and is enriched with our internal auxiliary data, which comes in the so-called onboarding files, which contains information about legal entities, instruments that our clients use in their trading activity. And then it goes to the trade data generator, which basically generates the output for one of those trade repositories I mentioned on the first slide. And again, after we have generated the data meant for trade repository, we validate it again. We perform sanity checks, make sure that it's consistent. And then again, if we have any errors on this stage, we notify our clients. And if we have some valid data, we process it further and submit it to trade repositories. After that, we wait for responses from TRs, and we again generate reports based on CME, DTCC, or Unavista responses. So it can either be accepted or unaccepted, and depending on the reason why it is not accepted, we can then notify our clients about the further actions that they need to perform. Or we can handle some of them from our side, so that we don't bother our clients with some requests. Okay, as Andreas mentioned, we had about 6 million transactions per day from Reg System in general, but Reg v1 currently processes most of it. And I will explain the discrepancy about the incoming transactions and outgoing transactions. First of all, different trade repositories require different actions. For, let's say, for trades, CME requires on position level, I will get to it a bit later, requires a new and a compression. And after that, we submit positions. So from one incoming record, we can generate up to, in some cases, even 8 transactions. So it might even get bigger, I mean, the outgoing messages. For the input, we have specs, which can be up to a lot of fields. And these specifications is a class that we designed for processing the input data, and every field has its own type. It has a name, it has a type, it has a flag if it's mandatory or not. It can also have a domain, it can also have a parser, let's say for different data formats, or again, it can have its validations. Validations can be either sanity checks, let's say on a integer format or data formats, or we can apply any validations required by the client. And those validations can be not just for one field, but for the record in general. Let's say if they have login name and I don't know, trader ID, we can, let's say, have a validation rule that some of these fields has to be filled. Otherwise, we fail those transactions and process everything else. So again, as I mentioned, we have multiple formats, a lot of sanity checks, and we try to keep it as smooth and transparent for the clients. So that basically we do not require much from the client. Basically, the only thing we require is the completeness of the data, and all the rest is on us. So, yeah, I guess that's just a sample of the report. And checks, we perform a lot of checks on every step of processing data. So we try to provide, and we do provide high quality service in terms that our clients are supported on every step, and they know what to do on every step. And if they don't, then they can ask questions, and we're always there to help us. And again, we are able, and we do maintain high volumes of trades. We can process even more. That's just the current state. And we also have a lot of system monitoring and smart data access strategies, like we are using RDS, EFS, S3. It depends on what data we process and what we do with this data. At some point, we archive data so that we do not overload our system. Let's say, I will get to it a bit later. For example, we optimize queries, and okay, probably it's better to go further. So I will explain the states on CME format. In CME format, so we have new, modify. Okay, so new is a new transaction, new trades, which we usually receive from the client. Modification is, well, it kind of speaks for itself. It's a modification. We can have it on position level, on trade level. Compression is what we send only on position level, so that the client is not charged for the transactions for trades and only charged for positions. So it's, for some clients, it's preferable. There are also cancellations, positions. Basically, Evgeny already mentioned positions. Those are current state of the client might trade an instrument for some period of time, and position just shows the current position with this instrument, and valuation shows the value of this position. And we have errors, or we call them error routes. Basically, these are meant for transactions that have been submitted erroneously for any reason that might be. So we have two approaches about dealing with data. So first we have this, as you can see, accepted until proven wrong. So this means that we suspect that we submitted data and it will be accepted. For example, with positions, it means that after we submitted position one time as new, the next time we'll just submit modification if it's just the same day or in an hour after the first submission, and we expect that it will be submitted, it will be accepted as well. Other approach means that we suspect that it might not be accepted, so in this case, next time, after the first submission of a position, we submit again as new. And if it has been submitted wrong, there was something wrong, and we received from a client either missing information or a correction to an instrument, then next submission will auto-correct it. So we kind of have auto-fix for some cases. Okay, after that, we have a task of parsing responses from trade repositories and sending reports to clients. Parsing responses is usually very straightforward because, let's say, CME has same format of the response as, they have two responses. One of them shows the errors, if there are any, or it indicates that everything has been accepted. And the other file contains just the data as we submitted it, so it doesn't have any problems. DTCC, on the other hand, has different formats of the response. They don't even use the same headers, which sometimes is a headache, but not really. So, and for some cases, we have already implemented automatic, either automatic or semi-automatic solutions, and we know how to deal with a lot of exceptions that might happen even on the TR side. It might be lost response or broken response. It doesn't happen too often, but we still have it sometimes. We also have we also run reconciliations against TR data. We usually do it once a month, as required by the regulations, and the query is quite smart. So for our 40 clients, and each client might have up to 6 gigabytes each of the response data, which is again much shorter than the actual submitted data, and it only takes like 1-2 minutes. So we are good with this as well. Okay, we also have a few systems which monitor, those are external systems which monitor our systems and tell us if we have anything pending, either the flow has not started or whereas it should have started, or we have some pending incoming files or pending responses, and in these cases we just know what to do, what to inform our clients about, and we also receive internal reports. Okay, just a second, back for a while. We also optimize the ways we use the data. For example, for position calculation, again, we have to calculate a position based on every trade that we've ever submitted. But in some cases, we can group trades and archive them so that we don't use them. Instead of, let's say, 10 million trades, we can use just 2 of them, because 8 million create no position. They don't affect positions. They kind of, they compensate one another. So let's say we have 1 trade for 2, 1 for -2, so the position for those 2 trades is 0, if they have same group. And those trades we can archive, and it results in higher performance. Also, Reg V1 system has a subsystem for integrating clients. You have to just feed a few parameters and few documents to this system. Let's say onboarding document, it's our internal document that the client sends us information in. We need also, of course, we need integration name, platform name, for which it is meant TR repository. and at least input spec file. Again, it's either a spec file, which is, again, we use when we're discussing the integration with the client, or just a sample file. And we analyze the sample file, and we decide what data types to use, which formats to use. And we also need information on the auxiliary flows, which can be like user flow to get the user data or to get extra prices, something like this. And so with those, with just a few parameters, you can get a completely structured, fully correct integration code, which will require minor changes in general. I mean, if it's a usual integration, it might even not require any changes. But for some custom integration, it might require a lot. But anyway, you will get the structure and the comments, and even any new guy who is working on this part of the system will just have to read the comments and write some missing methods, and that's it. Yeah, we also have a portal where our clients can see if there is anything going wrong, or they will see that everything is going really nice. So, and if they have any questions, they can run reconciliations of their own and ask questions. So, I guess that's it from my side.
Thank you very much, Dmitry. So, any questions on this? Yes, you. Where's the microphone? Can you just? Oh, there it is.
Hello, I'm Dmitry. So you told that you can generate specification based on the sample input. How do you make these guesses? How do you guess that this particular field is valuable for you? That this should be interpreted, and this should not be interpreted. How do you make these guesses?
You mean how to analyze the spec file?
Yes.
Well, at this point, it's really quick. I mean, if it's a number, we usually use an integer. If it's a floating point number, we use float type. If it's anything else, we use just string.
Okay, but it makes sense for example, CSV. It makes sense, but if there is some more complex format where is a lot of some unnecessary data, what about this? For example, 1,000 fields and you need only 10 fields.
Again, if it's a sample file, we consider every field as non-mandatory, and usually we work with CSV files, or if it's a database connection, it's already also kind of transformed into a set of fields, which we can kind of consider a CSV file, and for that we can use the same.
So you work with quite good clean data. Okay.
Yeah, it doesn't generate a fully correct spec. It might require some changes, but you will have to just analyze it and see if everything is correct.
Okay, and another question is about validation of this that spec class. It is declarative. It's quite good. Looks very nice. But you mentioned about some cross-field validation when, for example, only one field of two is mandatory. Is it done? Yes, it was in the very beginning.
Let's go here, right?
No, it was in the very beginning with a list of different fields.
This one?
No. Very beginning. Yes, this.
This one. Okay. Yeah.
And you told that there is a case when only one of two fields is mandatory. For example, when
in this spec, almost every field is mandatory. What
about the case when we need either of two fields.
Yeah, but in this case, if we have to have either of two fields, we set them both as non-mandatory, and then there is an extra layer of validations, and we perform this validation on the next step.
So
we mark
it
them
is just a Python code.
Yes, it's fully in Python.
Okay, thank you.
Thank you. You're welcome.
Any more questions? Yeah, there's one back there. Can you give him a mic?
Thank you for your talk. On one of your slides, you showed that you aggregate about 60 gigabytes of data per 2 minutes, approximately, right?
Yes.
How is possible?
Well, I won't show you the query right now. I don't have it right now, but it's
okay.
basically...
What database you use for aggregation or whatever?
You'd be surprised, but those response databases are SQLite. So those
Really?
Yes, this performance in SQLite.
This is only for aggregation, only for importing data plus aggregation.
Well, you see, we don't store in the response databases all the information that we submit. We take like 10 to 15 fields, and we store them in several tables. But anyway, based on the analysis we ran, we can use a few fields, and based on this set of fields, we can kind of trim down the amount of data that we actually have to process.
Okay, you have database which contains about 60 gigabytes of some logs, right? CSV files.
Not logs, the parsed response files from the trade repositories.
And when you run your some query, SQL query on the SQLite, this query runs about 2 minutes?
2 minutes, yes. For all the clients, not just for one.
Okay.
I mean, a straightforward approach took like 7-8 minutes for each client, well, depending on the database. For, let's say, 30 gigabyte client, 30 gigabyte response table, it used to take about 70 minutes. But after the optimization, it takes just 2 minutes for everything.
Okay, because on my project we use Reg System, which aggregates about maybe 25 gigabytes logs for 10 minutes maybe. And Redshift is column-oriented database which is aimed for aggregation. But SQLite is just a relation database, and there it aggregates data for 2 minutes. Could you show me query, please?
Not right now, sorry. But yeah, you see, it depends on the complexity of the trade or the data. It depends on the complexity of the analysis you need to run.
What kind of query? Do you use some aggregation functions, group by?
We need the statistics on how many trades are unique per month. So of each type, trades, positions, etc.
This is simple select, right? Select.
Well, it's a tricky select. Otherwise, it would have taken much more time.
Okay, thank you. It's really strange. I don't believe you.
Well, I can show you.
You should definitely have a look at SQLite. It's a very, very fast database.
Yeah, I know it, but it's a relation database, and it's not aimed for aggregation. It's kind of slow for aggregation, no?
Well, I think the main point is you need to get the data into the database, right? This is usually what's a bit slow. But if you have it in the database, then actually querying the database is really fast, because it's on disk, right? So you only have disk I/O. If you put lots of RAM with it, then it can cache all the data very easily. And so what you get here is you get really good performance. You get much better performance than Redshift, for example.
SQLite is working in RAM, yes?
It tries to load as much data into RAM as possible, right? And then it just works on the data that it has in RAM. It does not necessarily always go to the disk.
Okay, thanks. Yeah, makes sense.
So the interesting part about this whole reg business here that we've shown is that we can manage these huge numbers of transactions here, which also produce a huge number of errors. we can manage all this more or less automatically because of Python, because we can do all the exception management in Python, and we don't have to use human labor for this. And this makes it possible for us to do all this reg processing with just 4 people, which other companies cannot do. Other companies have huge teams sitting there processing all these the exceptions, and we've managed by using Python, by leveraging all the flexibility in Python to actually address all these things. And we can very quickly, for example, if we have a new issue that we find in the data, we can very quickly write something to address that issue so that next time around we don't have to process these things manually anymore. So this is a major advantage that you have with Python, and this is also something that you see in many other situations where you use Python. So we think that Python is actually the language to do data processing. All right, if there are no more questions, there's one more question here, okay.
Yes, one more question, I forgot. You talked about billions of messages, and you talked about some percent of exceptions, some errors. So what is the average percent of such exceptions? I mean validation exceptions.
You mean the ratio of errors from TRs or exceptions that we can have internally because of bad data format or something like this?
I think it's bad data format and maybe some very primary validation in terms of business logic.
Well, we don't have much exceptions because after we have agreed the format with the client, they usually send us the data in correct format. So I don't think it happens
There
really.
is always some human factor, you know. So,
but usually they use some of their systems so that the data is generated by a system, and it usually is correct. So.
But
just to give you an idea about what we're usually facing, if something goes wrong, it's usually a systematic error in the system of the client providing us with the data. Let's say they switched to a wrong data format, wrong date format, right? So they don't send the data in ISO format anymore, but instead they send it in some, text format, right? And so in those cases, what we see maybe 20,000 trades coming in which are wrong. Of course, it's because the error is always the same, we can go in, we can go fix it, we can write something that parses this new format that they send us, and then we can just simply reprocess everything. And Python makes it very easy for us to quickly address these situations.
Yes, but how often does it happen? For example, once a day, once a week, or 5 times a day?
For some clients, it doesn't happen at all, if they're really clever.
But for you as a company?
It depends. It's probably a few times a week.
A few times a week?
Yes.
Yes, this is what I wanted to understand. Thank you. Thank you very much.
So we have some more beer left that you can, about 150 bottles, so feel free to have some. We also have some more pizza, I think, yes. So you can have some more food if you're hungry. Thank you all for listening. Thank you all for staying this long. I hope it was interesting for some of you. If you want to talk to us, please approach us. If you want to contact us, please leave your contact details in the box there at the beer booth. And hopefully see you next time. Bye-bye.